To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter we discussed several things regarding the sound waves. Okay, now once again within this chapter we'll be coming or we'll be observing another effect given out by light waves. Here within this lesson part we'll be focusing about the refraction of light waves, my dear children. Refraction of light waves. So during the beginning of our lesson we discussed about what do you mean by the refraction process. I have given you a simple brief regarding the refraction. Okay, over there I have mentioned that the bending of light rays when traveling through different through media that has different optic properties was referred as the refraction. Okay, so within this lesson part in detail we'll be discussing about this refraction process. So my dear children, the refraction of light, this is the topic that we are about to discuss right now. So here it is given, when light is traveling through a transparent medium, it travels rectilinearly. Alright, we know that when light is going to transmit from a certain medium, it's going to travel rectilinearly. That means, my dear children, it is going to travel on a straight line. Okay, rectilinear means it is going to travel on a straight line, right? Very simple. So light rays are going to travel on a straight line when traveling through different media. Okay, not different media, when traveling through a certain medium. Okay, when traveling through a certain medium, light rays are going to travel on a straight line. Here it is given. Now let us consider an instance that a light ray entering from one transparent medium to another transparent medium. Now here, my dear children, we'll be focusing about the transmission of light rays from one particular transparent medium to another transparent medium. Okay, one transparent medium to another transparent medium, what is going to happen? Right, when light rays are passing from one transparent medium to another, what is going to happen? This is the one we are going to observe within this lesson part, my dear children, about the refraction of light. Now here it is given, let us do the activity given to study this phenomenon. So to identify what is going to happen with the light rays with passing from one transparent medium to another, we are going to do a certain activity. Okay, we are going to do a certain activity. Now let's see what is that activity. So here you are given with several instruments to carry out the activity. So studying the refraction of light, my dear children. Here you'll be needing these materials in order to get the necessary observations. So let's see what are the materials that we need. We'll be needing a water beaker, right? Then soap, then, my dear children, a laser torch, right? A laser torch. So these are the materials that we need. We'll be needing a water beaker, some soap, and a laser beam, a laser torch, or else a laser beam to get the light, my dear children. Okay, very simple activity. What you have to do, you have to take the water beaker, dissolve some soap in it and make a translucent solution, then direct the laser beam towards it and observe what is going to happen. Very simple. Okay, right then. So let's head on to see the method then. So here it is given, the method. Mix some soap in water in the beaker without allowing it to form leather. That means, my dear children, you know that when this soap is going to dissolve within the water, some amount of, like leather kind of a substance is going to create within the water. So in that case, right, if that thing is going to create, then we won't be able to observe the necessary things. So therefore, don't create the leather substance. Remember it. Just mix the soap without creating leather. Okay. Next one. Then direct a thin inclined beam of light using the electrical torch or the laser torch. So we have to use the laser torch here, because here we are going to direct a certain one beam. That's it. Okay, one beam. So by using a laser torch, we can get the necessary one beam without any trouble. So we are directing one beam into it. Okay, here. Then observe how the path of the light beam changes when it enters to the water. So these are the two instances. First, at the first instance, directing the light beam perpendicular to the water surface. That means like this. You have to keep it perpendicular, then direct it. And you have to observe the pathway of the light beam. Okay. Then at an angle you have to keep like this. Then you have to direct it towards the water beaker, and we have to observe the pathway of the laser beam. Okay, so here it is given, directing the light beam with an inclination to the water surface. Like this, with an inclination you have to direct the laser beam. First of all, you have to enter it like this, then you have to enter it like this. Then you have to observe what is going to happen. So it's very clear to us that, if you can see the figure very well, when it is perpendicular to the water surface, the laser beam travels on a straight line. However, when it is at an inclination, or when it is inclined, there is a bend. See, there is a clear bend between the two rays, the rays which are emitting and the rays which are getting subjected to refraction has a certain bend. Okay, there is a clear bend. So let's head on to the laboratory, my dear children, and let's do this particular activity, and we'll observe whether the bend can be observed in our experiment or not. Okay. Right, my dear children, now within this activity we'll be investigating about how does the refraction of light is going to occur. Now within this activity, they have been instructed to use a beaker with some amount of translucent water. Now here, as you see, when I place this thing over here, and when I'm going to direct the laser beam like this, so you won't be able to observe the light rays which are passing through this medium, my dear children. Right? However, you know that when I'm going to direct light like this, you can clearly observe the light rays which are passing from the translucent media. Right? However, if I'm directed like this, you won't be able to observe the light rays that are passing from the media which is over here. So in that case, my dear children, we'll be using this flat bottom flask so that we can pour water into it, this translucent water, and in order to observe the area quite well, I'm going to make the empty area or the empty part of the flat bottom flask translucent. How we can make it translucent? I can use this incense sticks, and I'm going to use the smoke of it to fill it with the beaker over here. Okay, flask over here. Right? So let's keep the flat bottom flask over here. Let's pour some water. Right, so now let's insert the smoke of incense stick into this particular container. You know that there is an empty part, so this empty part should be filled with some kind of a translucent material, otherwise you won't be able to observe the light which is coming from that medium, my dear children. Now here you can see that there is nothing, right? So we won't be able to observe it. So that's why I'm filling this thing by smoke so that you can observe it very clearly. So let's right, my dear children, now as you can see here, I have filled the container with smoke. Now when I'm going to light this thing, now you can observe the light rays passing from the medium. See, now you can observe it. So first of all, I'm going to direct light like this. So you can see the light rays which is passing from the top of the container towards the bottom, and there is no deviation in the light ray. It's very straight. Right now, so in the earlier case, now we have enclosed this thing by using a smaller beaker now. So you won't be able to observe it over here. So first of all, I'll use the inclined one, right? So like this. And now you can see it very clearly how it's going to refract. Right. So my dear children, now let's direct the laser beam and we'll observe. First of all, we'll observe from an inclined angle, like an angle. I'm going to insert the laser beam towards the container over here. Okay. Now let's see when passing through water, what will happen. Right. So as you can see, the light rays are directly passing towards the container, and you can clearly observe there is a bend in the light ray. Light rays are going like this and getting bent and traveling. See, there is a clear bend. As you can see here, there is a clear deviation in the light ray, my dear children. So it's getting bent very clearly. So you can clearly observe the bend. See, there is a clear bend. When I'm going to turn, the bend is also turning. So there is a clear bend between the light rays. There is a clear bend between the light rays, my dear children. Right? Okay. Now I'm going to remove this cup and we'll direct it from the top. So we have to insert it from the top like this now. See? Now there is no such deviation with the beam. Observe, there is no such deviation. However, if I am going to direct it like this, then there is a clear deviation. Right then. So this bending of light rays, my dear children, is referred as the refraction of light. You can clearly observe the bending process when I am going to direct the laser beam toward this translucent material. Right? Okay then. So let's head on to the classroom once more and we'll observe the other things on the lesson. Right, my dear children. So we carried out the experiment and you could clearly observe that in the first instance, where I'm going to direct the light perpendicular to the water surface, it's going to travel in the same straight line. The laser beam is going to travel in the same straight line when I'm directing it perpendicular to the water surface. But however, when I'm pointing it at an angle or with an inclination, what will happen? Light rays are bent and it is going to travel, okay, towards the water surface. Right, towards the water, light rays are going to bend and travel. So we'll write down our observations then. Observation 1. Light rays travel in the same straight line when the beam is perpendicular . when the beam is perpendicular to the water surface. So light rays travel in the same straight line when the beam is perpendicular to the water surface. So in the same straight line, my dear children, the light beam or the laser beam is going to travel if the laser beam is perpendicular to the water surface. If not, what will happen? Number 2, if sent in an angle then a bend can be observed. Right? So if sent in an angle, then a bend is observed. Okay? So light rays are going to bend and travel if you are directing it at an angle. If you are directing it perpendicular to the water surface, then light rays are going to travel on the same straight line. Okay? So here, if sent in an angle, then a bend is observed. Then the other observation is light rays are going to travel in the same straight line when the beam is perpendicular to the water surface. The two observations. So this bending process of light rays is the one which is referred as the refraction of light. Okay. So our conclusion is quite simple, my dear children. What is the conclusion? Under the conclusion, we can write down the light rays is showing a refraction when enter in one particular transparent medium to another transparent medium. Okay. So, you can write the conclusion. Light rays are refracted when passing from light rays are refracted when passing from one transparent medium to another. Right. So my dear children, light rays are refracted, right? Light rays are refracted when passing from one transparent medium to another. So refraction is the idea of, right? Refraction, in simple, refraction is the idea of bending of light rays when traveling from one particular transparent media to another. Okay, when transporting or when transmitting light rays from one particular transparent media to another, the bending of light rays is referred as the refraction of light. Refraction. So refraction means bending of light rays, my dear children. So here, light rays are refracted when passing from one transparent medium to another. So let's see now what is this refraction is. Okay, so you will be identifying the process of refraction in detail when you go further with the lesson, right? So let's see the other content, my dear children. So you are given with several questions here. Let's see. Try to answer the following questions while using the previous activity. Now we did the previous activity, no? And we even come into conclusions and several observations by doing that particular activity. Now you are given with certain questions here. Let's try to answer these questions then. Number 1. What are the two transparent media that the thin beam of light traveled through? So what are the two transparent media that the thin beam of light traveled through? Now, my dear children, when we are directing the light beam towards the water, okay, actually there are three media. However, let's consider about only two. Now, as you know, there are three media in the sense in here, you know that I'm directing, you know that I directed the light beam from our atmosphere or within our atmosphere. So the light is first of all going to travel through our atmosphere. That means from air. Then it is going to enter to the water by transporting through the glass, my dear children. Because over there was a glass, no? Glass tube, a glass beaker. We used a glass beaker, no? Right? However, my dear children, let's ignore about the glass. Right? As it is a very thin layer, let's ignore it. Very thin layer, no? So let's ignore it. We'll just focus about the air medium and the water. So there were two media, air and water. So we can write the answer. Air, water. These are the two media. So two transparent media, okay, air and water. At what place did the beam of light bend? At what place did the beam of light bend? Can you remember when it is directing like this? At here the bending started. That means on the place where the two layers are getting separated, okay, on the place where the two media are getting separated, from that line the rays got bent, okay. So this is water, this is air, from here to here, okay, from here to here. So bending started from the level, okay, from the surface of the water level, right, from the surface of the water level. So my dear children, we can write the answer. At what place did the beam of light bend? At the surface level of the water. So at the surface level of the water, right, the beam got bent. Next one. What is the reason for mixing soap into water? Why did we mix soap into water? In order to clearly observe the pathway of light. Because we are making the medium translucent. So within translucent media, we can clearly observe the pathway of light, my dear children. Okay. So to make translucent water to get better observations. Right? To make translucent water to get better observations. That is why we are mixing soap into water, my dear children. Next one. What happens when light is directed perpendicular to the surface? What will happen? So we studied that, or else I have shown you that it's not going to reflect at all. Reflect means actually it's not going to bend at all. Refract is the correct word. However, let's write it as bend. So it's not going to bend at all. It's going to travel along the same straight line, right? So we can write the answer. Light ray will not bend light ray will not bend it has traveled, or it will travel, right? As I have used will, then over here also I use will. It will travel, right? Light ray will not bend, it will travel in the same straight line. So light ray will not bend, it will travel in the same straight line. So this is the observation that we can take, right? If I'm going to direct it perpendicular to the water surface. If I'm going to direct it perpendicular to the water surface, then I can get this particular observation. So once again, let's see the questions. Number 1, what are the two transparent media that the thin beam of light traveled through? Number 1 is air and the other one is water. Then the two place, what is the place did the beam of light bend? At the surface level of the water. Over there I have even drawn the figure. What is the reason for mixing soap water? To make the translucent water to get better observations. Then what happens when light is directed perpendicular to the water surface? Then it is given light ray will not bend at all. It will travel in the same straight line. So these are the answers for the questions given, my dear children. Okay. Right then. Now for the definition of refraction. Let's see. In the activity, light rays have traveled from one transparent medium, air, into another transparent medium, which is the water, right? The surface where two media come to contact each other is known as the interface. So my dear children, the surface of the water, right? The surface of the water. Now that surface of the water is the point of contact of the two media, which is the air and the water. Okay. So that particular region, that straight line, is referred as the interface. This was referred as the interface. Light travels from one medium into another medium through the interface. So light is going to travel from one transparent medium to another through the interface. Okay. So from air to water through the interface, right? Then my dear children, it may be clear that always the change of direction of light occurs at the interface. It is important to mix soap water to see the beam of light in water. So the bending can be observed, okay? The bending can be observed on the interface. On the interface, my dear children. So the change of direction of light occurs at the interface, and we mixed soap water, right? We mix soap in the water in order to get better observations. Like I said, it's important to mix soap water to get to see the beam of light in water. In order to observe the light beam very well within water, right? To get better observations, we have make the water as a translucent medium. Okay, right. Then for the definition, change of direction of light when traveling from one transparent medium into another transparent medium is known as refraction of light. Refraction of light. And now we are coming into the definition of refraction. So over there I was telling about bending, and bending. Now the real, right? Now the real definition for refraction. So refraction is, my dear children, the change of direction of light. The change of direction of light when traveling from one transparent medium to another transparent medium. So bending means the change of direction of light. Okay, change of direction of light when traveling from one transparent medium to another transparent medium. This is the one which is referred as what? The refraction, my dear children. So during the refraction, what will happen? Light rays is going to travel through different media that has different optic properties. In simple, we can say that two different media that has two different densities. So when these light rays are going to travel through different media that has different optic properties, different densities, what will happen? The light rays are going to change the direction and travel. Light rays are going to bend and travel. So this bending can be observed within the interface. So interface is the line or the area which the two transparent media come in contact with each other. Okay. So my dear children, this is what do you mean by the refraction of light. The refraction of light. Change in the direction of light rays when traveling from one optic medium to another optic medium that has different optic properties or different densities, right? However, these two media should be transparent, otherwise the light rays will not travel at all, okay? Right. So once again, the change of direction of light rays traveling from one transparent medium to another is referred as the refraction of light. Then the other thing, the beam of light directed perpendicular to the interface do not occur refraction. Now in the previous activity, we could observe that. When I'm going to direct the light rays perpendicular to the water surface or to the interface, then my dear children, we won't be able to observe that refraction. Because if you are directing it perpendicular, then we won't be able to observe that, right? We won't be able to observe it. So my dear children, this is the one which is referred as the refraction, right? The refraction. Okay then. During refraction, the ray that is reaching the interface is the incident ray. And now, let's take a simple refraction. So let's imagine that this is the light ray which is coming towards the surface. Okay. So this is water, or else let's take this is air. And now this is water. So you know that light rays are going to bend and travel like this. Okay. So the light rays which is coming towards a certain surface or towards the interface, this light ray is referred as the, right? This light ray is referred as the incident ray. Right? The ray that travel after the refraction is the refracted ray. So the light ray which is getting bent and traveled is referred as the refracted ray. So this is the refracted ray. Right? refracted ray, incident ray. So the ray which is reaching the interface is the incident ray. The ray that travels after the refraction is the refracted ray. The point on the interface where the incident ray falls is the point of incidence. So in the same way as a reflection, my dear children, can you remember when we are discussing about the reflection of plane mirrors, reflection of the laser beam using a plane mirror? Can you remember when you are drawing the ray diagrams also? We identified about the point of incidence. In the same way, my dear children, you can observe, see here, this particular point. This is the one which is referred as this particular point. From this point, right, the bending has occurred. So this particular point is the one which is referred as the point of incidence. The point of incidence. From this point, the bending is going to start. The point of incidence, right? A normal line is also can be constructed at the point of incidence. I think you now know what do you mean by the normal. Can you remember? Normal is the perpendicular line. It is the perpendicular line drawn to the, right? It is the perpendicular line drawn to the point of incidence, right? Like this, it is the perpendicular line drawn to the point of incidence, right? So always this is perpendicular to each other. So this is the interface, the perpendicular drawn to the interface is the normal through the point of incidence. This is the normal. So like in the same way where we discussed about the reflection, here also you can observe two different angles. Angle between the incident ray and the normal. Angle between the refracted ray and the normal, INR. So this is the incident angle. This is the refracted angle or the angle of refraction, the angle of incidence. Okay. So these factors can be identified within a refraction. So I'll name this one. This is the normal. This is the normal. And my dear children, this is the point of incidence. Right? Point of incidence. Right. So these key factors can be identified within a refraction. So I'll name INR as well, right? So we'll name the INR as well. So here I, this is the angle of incidence, R, this is the angle of refraction. So I is the angle of incidence, R is the angle of refraction. So these are the special things that we can observe within a refraction, my dear children. Right? Okay. So the light ray which is coming towards the interface. So this blue color one is the interface. Right? So see, during refraction, the ray that is reaching the interface is the incident ray. This is the interface, the blue color line. So the incident ray is the one which is reaching towards the interface, the incident ray. Then, my dear children, the ray that travels after the refraction is the refracted ray. Light ray which is going to travel after the refraction, that's the refracted ray, right? The refracted ray over here. The point on the interface where the incident ray falls is the point of incidence. So over here, where the incident ray is going to fall, this point, this is the point of incidence. From the point of incidence, we can observe the refraction process, which is the bending. Then, my dear children, like in a reflection, we can create a normal line which is perpendicular to the interface at the point of incidence. So this is the normal line. So when you draw out the normal, you can create two different angles, which is the angle between incident ray and the normal, which is called as the angle of incidence. And the other angle is the angle which is created between the normal and the refracted ray, which is also referred as the angle of refraction. Okay. So these are the key things that we can observe during a refraction, right? The key things that we can observe during a refraction. Now, remember, in a reflection, light rays are going to bounce back. However, in here, there's no such thing. Light rays are going to travel through the medium, however, by bending, not in the same direction. Okay. This is the difference between the refraction and the reflection. On the reflection, it is going to bounce back. But in here, going through by changing the direction or by bending, right? So this is what do you mean by the refraction and the reflection, the main difference. Okay, don't get confused with the two different theories, my dear children, right? Okay, so the refraction can be given as like this, right then. So my dear children, this is the refraction and the components that can be identified within the refraction. Okay, now let's head on to see the other contents. So in the same way which I have took in the earlier, right, you are given with a good, right, I mean like a clear figure over here to identify the components regarding a refraction. So it is given here. The way of refraction occurs when a light ray enters from air to water can be shown by the ray diagram as in the figure. Now, you know that this particular diagram is called as the ray diagram. This is the one which is referred as the ray diagram, my dear children. Now, in a ray diagram, we use the light ray and we are going to draw and show the pathway of light ray. So this is the pathway of light ray that can be observed during a refraction. So here it is given the incident ray, the light ray which is coming towards the interface. So this point is the point of incidence. Then the line, the perpendicular line to the interface which is passing through the point of incidence, that is also referred as the normal. So this is the normal, my dear children. You know that it is an imaginary line, means that we have to draw it out, right? In a normal refraction, we won't be able to observe that thing. So it's an imaginary line, a man-made one and an artificial one, okay? So in order to make our refractions more convenient, we draw this thing, the normal, and also during the reflections also we can we draw these things, right? The normals, right? So normal is very important to identify the incident angle or the angle of incident and the angle of refracted or the refracted angle, right? So the angle between the refracted ray and the normal is the angle of refraction or the refracted angle. The angle between normal and the incident ray is the angle of incident or the incident angle, right? Incidence angle. So these are the factors that we can observe or the components that we can observe during a refraction. So here you are given with the definition. The way of refraction occurs when a light ray enters to air to water. Okay, right, my dear children. Now Let's see what are the other contents then for your extra knowledge. Light travels in a definite velocity in a given medium. Velocity of light differs from medium to medium. The speed of light is a universal constant, my dear children. It is a universal constant. Universal constant means nothing. I mean, like no matter, matter means any solid, liquid or a gas, no matter can break the speed of light. It's a universal constant, right? So, in here, normally the usual speed of light is 3 into 10 to the power 8 ms minus 1, but however that is in a vacuum. See, 3 into 10 to the power 8 ms minus 1 meters per second. I think in your mathematics part you have studied about the scientific notation, right? So here it is mentioned by using that scientific notation. Okay, so if you write it down by using a number, it's like this: 3 into 10 to the power 8 means 3 and 8 zeros. 1, 2, 3, 4, 5, 6, 7 and 8. So if you separate the zones, it's like this. Okay, 300 million meters per second. So to make this thing somewhat convenient, let's convert meters into kilometers so that we can get a good idea. So when you are converting meters into kilometers, what you have to do, you just need to divide it by 1000. Okay, you just divide it by 1000. So meters can be converted into kilometers then. So when you divide this thing by 1000, 3 zeros to 3 zeros are getting cancelled down. That means, my dear children, here 300,000 kilometers per second. So it's a terrible speed. I mean, like the maximum possible speed which a matter can reach. It's the maximum possible speed which a matter can reach. Actually, this speed of light haven't been actually satisfied like up to 90%. No, none of the materials have the ability to travel in the speed of light. That's the maximum. However, at least we won't be able to travel at 90% of the light speed. Okay. So usually the highest speed that we have achieved up to now is like about 50 to 60% of the light speed. So not even closer, at least like half, right? It's like half. Actually, it's somewhat even more less than that. However, for subatomic particles, some subatomic particles like electrons, they have the ability to travel at the speed of light. Okay? They have the ability to travel at the speed of light. And my dear children, let me tell you something interesting. There is a certain thing which is going to go even beyond the speed of light. Okay, that's the expansion of universe. You know that our universe is keep getting expanding because of the Big Bang. I think you have heard about the Big Bang, right? So because of the Big Bang, our universe is keep getting expanding, right? So this expanding process of the universe is going to go beyond the speed of light. Okay, actually we won't be able to measure it, the speed. The scientists have predicted that the expansion of the universe is happening even beyond the speed of light. However, any material, right, no matter the material, the type of the material, matter, none of the matter, right, cannot achieve the speed of light. If so, it's not going to behave as a matter at all. So you'll be learning these interesting things when you go further with your grades, my dear children. Okay, just for now, for your extra knowledge, I have given you these things. So remember, usually light is going to travel like 300,000 kilometers within 1 second of a time period. Okay, within 1 second of a time period. 300,000 kilometers within 1 just second of a time period. So let me go somewhat different kind of a thing. It's not related with this lesson, but however, for your extra knowledge, I'll give you this thing. So have you heard about the thing called light years? I think you have. In grade 8, you have heard about the thing called light years. So what do you mean by a light year then? So to measure the distance between stars, we use the term called light years. What is the light year? You know that light is going to travel 300,000 kilometers within 1 particular second. So the distance that the light is going to travel within 1 year of a time period, within 1 year of a time period, is referred as a light year. Which means, here this is for 1 second, no? Now multiply it by 60 to get 1 minute. Again multiply by 60 to get 1 hour. Multiply it by 24 to get 1 day. Multiply it by 365 to get 1 year, right? So imagine how much big is the unit light year. So stars are like light years away from us. So in kilometers, we won't be able to even mention it. That's why we are using the term light years to measure the distance between stars. So these things are somewhat extra knowledge for you guys, my dear children, right? So once again, let's see. So light is going to travel at a certain velocity in a vacuum. This is the maximum possible speed which a matter can reach, which is equal to 300,000 kilometers per second, right? However, my dear children, the velocity of the light is going to change from one particular medium to another. That's because of the change of the density, right? So from one transparent medium to another, their density is going to change. Therefore, what will happen? The speed of the light is also going to change. So within water, it is going to travel at 2.25 into 10 to the power 8. That means 225,000 kilometers per 1 second. Then in here, within glass, 200,000 kilometers per 1 second, or else 2 into 10 to the power 8 ms minus 1. Okay. Then the next important point. Refraction of light occurs because of change of its velocity when traveling from one medium to another. Actually, this bending is like a hallucination, right? That's what our brain says. However, it's not the actual one. The brain is going to project this thing as a bending because of change in the speed of light rays. What actually happens in here is not the bending of light rays, but the change of speed in light rays when traveling from one particular transparent medium to another. Okay, so when transmitting from one particular medium to another, the bending of light rays is not the refraction, but change in the speed of light rays. That is the refraction. However, my dear children, we are sensing that the light rays are getting bent, or the light rays are going to change the direction and travel during a refraction. We won't be able to capture that change in speed. So instead, our brain gives a signal, the light rays is going to change the direction and travel. Okay, that's how we observe. But that's not the one which is going to happen here. But it's going to change the speed and travel. Okay, so change in the speed of light. Because of the transparent properties in transparent media is what is actually meant by the refraction. However, for our convenience, we refer this thing as the bending of light rays, or else change in the direction of light rays. So I hope you got the idea very well, right? All of these things are for your extra knowledge, my dear children, right? Then let's head on to see the other contents in the lesson. So studying how a narrow beam of light refracts when directed into a glass block. Now my dear children, we are going to take a certain glass block and we are going to observe how the refraction is going to occur through a glass block. Okay. So when doing this activity, then we'll be needing these materials. Let's see. We'll be needing a glass block for sure. Then an A4 sheet to complete the ray diagram. Then pins, right, pens. Then my dear children, over there, here we have to use, of course we have to use a laser torch or else a laser beam in order to get the light. Then a ruler and a pencil to complete the ray diagram. Ruler and the pencil to complete the ray diagram. So these are the materials that we need to find out, right, the process of refraction. See, we'll be needing a glass block, an A4 sheet, pens, laser torch, a ruler and a pencil to complete the ray diagram. Okay, right. Then now let's head on to see the method. Then my dear children, you are given with the method over here. So spread the sheet of white paper on the table and place the glass block on it. So you have to place the glass block, right, like this. Then my dear children, direct an inclined beam of light on the glass block as shown in the figure. So as per to the figure, you have to direct a light beam, right, at an inclination, remember. Next one, fix 2 pins on the path of the incident ray and the other 2 pins on the path of the light ray that travels away from the block, right? So you have to fix 2 pins on the pathway of the incident ray and the other 2 pins on the pathway of the light ray that travels away from the block. So you have to keep 2 pins over here, then 2 pins over there, right? Sketch the position of glass block using the pencil. Remove the glass block, the pins and the torch. Complete the ray diagram. Now what you have to do? Take the pencil and draw the place where the glass block placed. Then my dear children, you can remove the pins. Take them out. Then take the glass block out. Then you can take the A4 sheet and complete the area which has the glass block. Then you can direct, or by using a straight line, you can draw the incident ray. Then you can draw the refracted ray, right? The ray which is going, we can't draw the refracted ray just now, right? We have to first of all we have to draw the ray which is going to emerge from the other end. So we'll draw the emerging ray at the other end. Then after, you are going to draw the refracted ray. It's very simple. What you have to do, you just need to take this point and this point, then from a ruler, you just join the 2 points. So this is the way of doing our activity, my dear children. It's very simple. Okay. It's very simple. By doing this particular activity, you have the ability to identify the process of refraction, right? Now let's head on to our laboratory and we'll continue with the experiment. And once again, we'll come back into the classroom to write down our observations. Okay, so let's head on to the laboratory. We'll do the activity and we'll come back to the classroom to write down our observations. So my dear children, within this activity, we'll be investigating further things related to the refraction of light. Here we are going to investigate how does the refraction of light is going to occur through this block of glass. So to investigate about the refraction through a block of glass, I have with me a glass block, then an A4 sheet, white color A4 sheet, few pins and also the laser box. So what I'm going to do here is I'm going to direct a beam of laser like this, and then what I'm going to do is I'm going to draw out the structure of or the position of glass block. Then by using the refracted ray and the incident ray, I'm going to join those two and create how, or to observe how the refraction is going to occur through the glass tube, right, glass block. So first of all, I'll remove this thing. First of all, we have to mark the position of glass block on the A4 sheet like this. Right, now let's direct the laser beam. Right, so here like this you have to adjust the laser box. Right, so this is the light ray which is passing from the laser box, my dear children, and this is the one which is referred as the incident ray. And the light ray which is coming from over here, this is the refracted ray, refracted ray. So what I'm going to do right now is going to use these pens and point like this. I'm going to point 2 pins right, my dear children. Now let's remove these things gently. Now let's draw out the structure by removing the pins very carefully. So I'll place a tape like this so that it would not move. Okay. Right. Okay, now let's draw the line, my dear children. First of all, the line which coming towards the glass block. Then the line which is going away from the glass block after the refraction. Right, my dear children. Now let's join the 2 lines from a straight line like this. So as you can see here, there is a clear deviation in the path of the light ray. See, there is a clear deviation. So this is the glass block. I'll mark this is as AB. So this is AB. AB is the incident ray, which is the light ray coming towards the glass block. Then BC, B to C, that's our refracted ray, my dear children. So here you can clearly observe the light ray is coming like this and going like this, and the light ray is clearly bent when passing through the glass block. The ray which is coming out of the glass block is referred as the ray of emergence or the emergence ray, right? So once again, when it is emerging from the other side, once again you can clearly observe, right? See, there is a clear bend. So this is the light ray which is coming originally. So there is a clear bend here. When I'm going to put the ruler to the original straight line which is through the glass block, you can see there is an angle over here, right? That angle is created because of the refraction of light, and even in here also you can observe there is an angle. So this is the line of the ruler, my dear children, the straight line. So this is the angle which is getting created. So there is a clear bend in the light ray which is passing from the glass block right then. So let's head on to the classroom, my dear children, and we'll observe the other contents in the lesson. So my dear children, as you have observed, I have prepared that A4 sheet same as like this, identical to this figure, right, which is over here. So we could clearly observe the refraction process, right? We could clearly observe the process of refraction without any trouble. So you can write down as an observation, it's very simple. Light rays are refracted by the glass block. According to the figure. So according to the figure, my dear children, given in here, we can clearly observe that the light rays are refracted by the glass block, right? So here, this is the glass block. The incident ray, the ray which is coming towards the interface, then the normal, then that bending process, then again the normal, then again to have the same angle which is over there, it's going to bend and travel, right? The light ray which is coming or which is emerging from the glass block is referred as the emergence ray or the ray of emergence. This ray which is inside the glass block is the one which is referred as the refracted ray. Okay, refracted ray. The angle between the incident ray and the normal is the incident angle. The angle between refracted ray and the normal is the refracted angle. Okay, always you know that these two angles are getting equal to each other because of the alternate angles. See, to the sign of Z, these things are creating alternate angles, no? So because of that, these two angles are equal to each other, refracted angles. Right, my dear children? So within this activity, we have studied about the refraction process which is going to happen through a glass block. And we identified what kind of a thing is this refraction is. So actually the refraction is, my dear children, the bending of light rays. So what is the principle behind this bending process? How we can observe this thing as bending? It's mainly because of the change in the velocity of the light when traveling from one particular transparent medium to another. Velocity in the sense here, the speed of the light, okay? Remember, speed of the light, change in the speed of the light. Light is usually traveling at a speed of 3 into 10 to the power 8 meters per second. That means 300,000 kilometers within 1 second of a time period, right? That's the usual speed of light through a vacuum. So when these light rays are going to transmit through other transparent media, the speed of light is going to reduce. So this reduction is observed as a bending. We are sensing that thing as a bending, right? Or else the change of direction in light rays. This is how we observe the refraction process. Actually, what is happening here is the reduction of speed in the speed of light, right? So these are the things that we have learned within the process of refraction. So we identified the process of refraction first of all by using a laser beam directed towards a water beaker. Then, my dear children, we studied about the process of refraction by using a glass block, and we identified several factors same as the process of reflection. So the light ray which is coming towards the interface is the line between the two media. It's the separation line between two media, okay, two transparent media. So the incident ray is the ray which is coming towards the interface, okay, incident ray, the ray which is coming towards the interface. Refracted ray is the light ray which is getting bent, right? It is the light ray which is getting bent after traveling through the second transparent medium, right? Then to the point of incidence, that's the point where the bending is going to happen. So to the point of incident, perpendicular to the surface or to the interface, we can draw out a normal, right? So angle between the incident ray and the normal is the incidence angle. The angle between the reflected ray and the normal is the reflected angle. These are the key factors that we can observe within a refraction, right? Within a refraction of light ray. However, in a glass block, my dear children, after the refraction, the light ray is going to emerge from the glass block. So that special light ray which is emerging from the glass block is referred as the emergence ray. So these are the key factors, key components that we have identified within a refraction. Okay. So my dear children, with that I am going to finish up the chapter. So within our next chapter, we'll be studying about the main effects caused because of the process of refraction. There are several effects which is going to create because of the process of refraction. So we'll be discussing about those effects in our next chapter.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.